Hi friends, welcome to MATLAB school. In this simulation, we are going to see the comparison of PI, PID and fuzzy controllers for controlling the speed of BLDC motor. The same model, all the three models are available for download from the link given in the description. If you want, you can download it. This is the PI controller. Here we have the uh, BLDC motor model. If you want to change any parameters of the machine, you can change it. So inside this block, we have the data coming from Hall sensor that will be converted to EMF. Then that back EMF value will be converted to gate signals. So this is the truth table, which represents the conversion of EMF to pulses. This is the reference speed that is fed as input, and here we have the PA controller. Okay, so the PA controller is tuned in such a way that it will the error between the speed, the reference speed and the actual speed will be minimum. Okay, let us simulate the model. See, the simulation is running. Here we have the model running. Since the reference speed is 1500, it is settling around 1500. Okay, so in this scope, we can measure the values of overshoot, undershoot, as well as the settling time of speed. See, here you can see the overshoot 11.78, undershoot is 1.9, and settling time is 19.583 milliseconds. Right? Like the same way, we can measure the torque as well. Right? See, I have used the mean block because there will be a huge torque ripple. So to get the mean of that, to average out the ripple, I am using the mean. Right? The model is running. It has stopped. See, here we have a overshoot of around 11.79%. Let us see the performance of PID controller. Okay, this is the PID controller. Here you can see the values of KPKA and KD. Okay, I'm going to simulate this model. We can simulate it for 0.2 seconds. Okay, the model is getting simulated. Let us see the speed. See here, it is trying to settle without any overshoot. But there is a slight undershoot. See, as you can see, there is no overshoot. But in PID controller, certainly we have some undershoot. See, you see the settling time. Settling time is quite high when comparing it with a PI controller. But the advantage of this method or this controller is the absence of overshoot. Okay, the simulation has stopped. Let us see the torque now. Okay, so this is the torque. as well as we can see the uh, stator currents. These are stator currents. Okay. And finally, let us see the performance of fuzzy controller, right? See, here we have the uh, fuzzy, right? Let us run this model. See, before that, the fuzzy fish file ff1 should be kept in the workspace. See, then only we can uh, run the model, otherwise we cannot run that model. Okay. Let us see the fuzzy rules. We shall open it. Open from workspace. Name is ff1. Okay. So here we have error input. Okay. I have used fuzzy with 7 membership function, and this is uh, change of error input, and finally the output. Okay. So I'm going to run this model. Here we have limiters to limit the error as well as the change of error. Okay. Other things are same. The model for PI, PID and fuzzy controller is the same, only the difference lies in the controller. Let us run this model. See here our set speed is 1000. So you can set any value. This fuzzy will settle the speed at the reference speed. Okay, fuzzy has started. Yes, it is running. Let us see the overshoot and undershoot. See, there's a significant overshoot in fuzzy. Let us see the settling time. Yes, it is coming down to 1000 RPM. Yes, the speed is hovering around 1000 RPM. That's the set speed. Let us wait for the overshoot, undershoot, and settling time values. See, the values has come. Overshoot is 17 percentage, undershoot is 1.9 percentage, but the advantage is its settling time. See, the settling time is 7.411 millisecond. Fuzzy is making the system to settle very fast. Okay, let us stop this model here and we shall run the fuzzy for 1500 rpm. Let us see how it is work, how it works. Let us start the simulation. Yes, fuzzy has started. Yes, speed is gaining. Yes, yes, it is settling at 1500 rpm. See, for 1500 rpm, the overshoot is very less. Let us wait for the results to come here. Yes, you can see the results. Overshoot is very less, 2.57. Undershoot is 1.9 and settling time is very small, 2.8 milliseconds. Okay, so that's the advantage of fuzzy over PI and PID.